At first glance, it looks completely still, a giant rocket standing silently against the sky, waiting for launch. But look closer. This 16 million pound machine is actually moving, very slowly. At just 1 mile per hour, NASA's largest and most powerful rocket is making one of the most important journeys of its life. Before it can travel hundreds of thousands of miles into space, it must first survive a 4-mile trip across Earth. And carrying it is a machine unlike anything else on the planet. Meet the Crawler Transporter. Costing $144 million and large enough to nearly fit an entire professional baseball infield on top, this enormous vehicle is the largest self-powered machine ever built. Without it, NASA's most ambitious mission in decades, the Artemis program, would never leave the ground. Every mission to the moon begins here, not with a launch, not with a countdown, but with a slow crawl across a rocky road. Moving something this massive is no simple task. The crawler is so large and complex that it takes a team of 25 to 30 highly trained engineers and technicians to operate it safely. Every person has a critical role. Drivers guide the vehicle. Engineers monitor vital systems. Technicians oversee the engines, pumps, hydraulics, and leveling equipment. Others walk alongside the crawler during the entire journey, watching every movement and scanning for potential problems. Because when you're carrying billions of dollars worth of technology, there is no room for mistakes. The people walking beside the crawler often have a better view than the driver himself. They constantly communicate what they see, helping guide one of the most valuable loads on Earth toward its destination. Even driving the crawler is unlike driving any normal vehicle. There are driver cabs on opposite corners of the machine. When it's time to move in the other direction, the driver doesn't simply reverse. Instead, they leave one cab, walk across the massive vehicle, and continue steering from the cab on the opposite side. And that's only the beginning of the challenge. The journey may be just 4 miles long, but it isn't a straight path. The crawler must carefully navigate curves and turns while keeping its enormous cargo perfectly stable.
The ground's not always flat, so we have this jacking and equalizing leveling system that we use to maintain level throughout the transport of the Artemis vehicle. We have an automated system that actually kind of keeps track of our parameters. When we're going up the slope itself, we have one end of the vehicle jacked all the way down.
One wrong move could have catastrophic consequences. That's why every operator must understand the machine inside and out, all 70,000 individual components. Becoming certified to drive the crawler isn't something that happens overnight. For most people, it takes between 1.5 years and 2 years of training before they are trusted with the controls. The responsibility is enormous, but so is the machine itself. The crawler's story began in the 1960s during the race to the moon. Built by the Marion Power Shovel Company, the original design was adapted from giant mining equipment. At the time, it was engineered to carry up to 12 million pounds using locomotive-powered systems. Decades later, the machine that once carried the Apollo rockets would face a new challenge. NASA needed it to carry something even heavier, the Space Launch System.
They're called our traction roller assemblies. This is what supports the entire weight of the crawler. These trucks will constantly spin all around this, and these will support everything, including we put the rocket on top.
When we started replacing these 88 roller bearings, we did them in one truck at a time, so that would be 22 at a time. Then we took it out for a test run, and that would be 6 months worth of work there.
To prepare for this mission, engineers spent years upgrading the crawler. One of the biggest improvements involved replacing and strengthening the massive roller assemblies that support the vehicle's weight. These components carry everything: the weight of the crawler, the weight of the mobile launcher, and the weight of the rocket itself. In total, upgrading and testing all 88 giant bearings took 5 years. 5 years of work for a journey that lasts only a few hours.
Before the upgrade, they were originally designed to carry 12 million pounds. And now with all of our upgrades, we can carry at least 18 million pounds.
Hidden inside the crawler is a maze of engines, pumps, electrical systems, and hydraulic equipment that keep the giant moving. Every system must work perfectly, because failure is not an option.
So behind me here is our Alco engines. They're 2,750 horsepower. These engines are original to the crawler. I mean, they've never been replaced. They're one of the few still remaining things from the original NASA program. And this is our Cummins AC generators. These provide AC power for all our onboard systems, including our motors for our pumps, our fans that you're standing directly below here to actually introduce clean, cool air into the engine room for the techs that are in here.
Before that can happen, the crew performs a complete inspection. Every section, every system, every detail. Only when everything has been checked and verified do they receive permission to start the engines.
We check all the different pins, cotter pins, quarter stocks out that holds the track together. We check every single one of them on every single belt just to ensure that they are there, because we don't want to break a belt on the way.
Slowly, the giant comes to life. The journey begins. As it moves forward, engineers and technicians walk alongside it. Known as walkers, they act as the crawler's eyes and ears, constantly searching for anything unusual. Hour after hour, the machine inches forward. Then, finally, it reaches the vehicle assembly building. The driver carefully brings the giant vehicle to a stop.
We are slowing down our speed pot, bringing the crawler to what we call a normal stop by just dialing back, slowing down gradually, giving all of our systems an opportunity to adjust and just slowly come down.
But even parking the crawler is a major operation. It takes around 14 crew members just to connect the vehicle to external power. Every step is carefully planned. Every movement follows strict procedures, because the next phase is what everything has been building toward: the rocket. Soon, the Space Launch System and its mobile launcher are secured on top of the crawler. Together, they form one of the heaviest loads ever transported on land.
The crawler actually crawls or traverses underneath the vehicle and the mobile launcher. Once we're positioned correctly underneath these gel cylinders, we jack up, lift up the whole vehicle off the mounts.
Now the real journey begins. Slowly, the crawler leaves the vehicle assembly building and starts making its way toward the launch pad. Ahead of it, a truck sprays roughly 30,000 gallons of water onto the specially designed roadway.
The rocks that we roll on, as we crush them, it creates dust. These motors below us here suck in a lot of air to keep them cool while we're rolling, so that dust will get caught up in those filters and they'll clog them up. So by wetting all of the rock, that keeps the dust level down, and then it also changes the friction on the rocks, so it makes them easier for us to turn.
The water helps stabilize the rocky surface as the crawler crushes and compacts the stones beneath its enormous tracks. Foot by foot, minute by minute, hour by hour, the giant machine continues its steady march. There are no sudden movements, no bursts of speed, just patience, precision, and engineering on a scale few people ever witness. After 10 hours and 28 minutes, the crawler finally reaches its destination, the launch pad. Carefully, the giant lowers the Space Launch System into place. For now, the rocket will remain there for testing, rehearsals, and final preparations. Soon, engines will roar, the ground will shake, and humanity's next journey into deep space will begin. But before the thunder of launch, before the countdown, before the rocket climbs toward the moon, everything starts here, with a machine moving at 1 mile per hour and a slow 4-mile journey that carries the future of space exploration on its back. If you enjoyed this story, don't forget to like, subscribe, and join us for more incredible journeys into science, engineering, and space exploration, because every giant leap for humanity begins with a single step, and sometimes that step moves at just 1 mile per hour.